Good evening. This is the relearning for the wave unit, the most recent and last test of the year. We're going to start by going over the notes. If you have these written down, you can just show them to me instead of writing them down again. But it is really, very, very important that you use these notes while you do the relearning. I will not let you take the retest unless you can show me all of these notes. So I'm going to walk through them. If you have the notes already down, feel free to skip to the last slide of notes. Those are going to be new. So you need to add those to your old notes that we took during the unit. All right, so the four main definitions here: amplitude, the height and the depth of the wave, from the middle line to the top, from the middle line to the bottom. Frequency, the number of waves per second or another time unit. This is not speed. Light waves all move at the same speed. Sound waves all move at the same speed, but they come in different frequencies. Wavelengths is the distance from crest to crest or trough to trough, from the length of a wave, from the beginning of one to the beginning of another. That same spot on the wave. A medium is what the wave is traveling through. Most waves go through water or air. Our main type of wave we talked about is a transverse wave. That's when the wave moves in one direction and the stuff that it's traveling through, that medium, is moving at right angles to the direction it's moving. Example of this would be a string in a guitar or in electromagnetic waves. The string moves back and forth, and the wave moves towards the listener. The electromagnetic waves, the stuff it's going through moves back and forth, but it moves towards the viewer. This is in a diagram of that. The medium is moving up and down while the wave is moving to the right. A longitudinal wave is a wave in which the particles of the medium, the stuff it's traveling through, move back and forth in the same direction of the motion of the wave. Example of this would be a sound wave. This is something that we really, really struggled with. This would be an example of where this actually is right from the test. I use the same diagram. This is a slinky. So this is not every up and down is not one wave. This would be one curl of the slinky. And so remember, a wavelength is from one spot on one wave to that same spot on another. So in this diagram, it's from the middle of one compression to the middle of another. Most of you tried very, very hard to count the number of curls of the slinky. That's not what we're talking about here. This would be a little bit more than two waves. So compression, rarefaction, that's a wave. Compression, rarefaction, that's a wave. You need to have both of these drawn in your notes. I will not let you take the retest unless you have these drawn in your notes to the best of your ability so that actually makes sense. You also need to know about energy in sound and light. In sound, the amplitude is the volume of the wave, the volume of the sound, while the frequency of the wave is pitch, how high or low a note is being played. Light would be brightness, intensity is going to be the amplitude, while frequency is going to be color. We need to know that higher energy are going to be higher danger. So an example of something with a high frequency might be ultraviolet waves. It could cause cancer. Amplitude, bright light can do damage. So the higher that frequency, so on the test, something that a lot of you got wrong was you said UV waves are the most dangerous. But that's not true. Gamma rays have a higher frequency than UV waves and cause more damage than UV waves. Sound, really a long exposure can lead to damage if you're listening to ultrasonic sounds, and loud noises can also damage your ears. We need to know, this is not particularly important if you do not have this down, just know that you can go skip this. Light travels at 300,000 kilometers per second. It is the same speed. Doesn't matter if it's blue light, red light, doesn't matter. They all travel at the same speed. That was the big thing from the And a light year is a distance, how far light travels in 1 year. Electromagnetic waves, you don't have to really memorize much about these. You just have to be able to use this. This is the frequency, and the further you go to the right, the higher the frequency. So these are those gamma rays. They have very, very, very high frequency waves. They are the most dangerous. If we were to rank them, gamma rays would be most dangerous, X-rays would be less, and ultraviolet are less than X-rays, which if you think about it, you can go outside and be exposed to ultraviolet a lot before you get damage. You're not going to get cancer from walking outside immediately. It takes repeated exposure and long exposure. This is the new part of the notes, so if you did not if you are using your old notes, you need to write this down. This is new. You need to know that speed equals frequency times wavelength. I will give you that equation, but you need to be able to use that. Additionally, you need to know that frequency is the number of waves that pass the spot per second. This was something you struggle with on the test. I actually threw this out of the test. You need to know that for the retest. It's essentially what a frequency is. It's the number of waves per second. The period then is how long it takes one wave to pass. Period equals 1 divided by the frequency, and then frequency also equals 1 divided by the period. So you need to write that down. You need to be comfortable with that. So you have to see if I'm looking for frequency, it just depends on what I'm given. Am I given the waves and seconds that pass by, which some of them times I did? Sometimes I gave you wavelength and speed, then you need to use that first equation. But if I give you period, then you need to use the last one. So all of those are different ways to get the frequency, but you have to see, what did I give you? What information do you have? I'm going to switch to my doc cam here, and we're going to go through this together and just do a couple practices. So looking at the first section of the test, for the most part, what we just struggled with is the frequency. The other big issue we had was measuring. I'm going to do some practice measuring and remind you what you need to do. Before I do that, never mind, it's on my ruler. So if you were off by 1/10 of a centimeter, I let it go. I said that's close enough. But if you were off by more than 1/10, then I said no, you're not measuring accurately. So make sure you take your time. Wavelength, amplitude is the height of a wave or the depth of a wave. So you need to measure from that equilibrium point. So if we're looking at wave 2 and putting the 0 mark right on that equilibrium point, and I'm going to measure to the top. So wave 2, I hope you can see the top of that wave is right at 1 centimeter. So I didn't measure from the depth to the top. I measured from the middle point to the top. So you need to practice this. Wavelength, so this was 1 centimeter, and I can measure to the 10th, so I'm going to put a 0 because I really know that it's just 1 centimeter. Wavelength is from the beginning of one wave to the beginning of the next. So I'm going to measure this one, and I'd say that's 1.5 centimeters. Sorry, I know the glare is not awesome right now. So it's 1.5 centimeters, just right at this point. I apologize, I put it in the wrong spot. This is wavelength. What is the amplitude? All right. So that was one thing that I thought was pretty easy, but obviously I underestimated. Another thing then we did when we got to this set of questions here at the bottom, I'm going to just show you this question. It says, what is the speed of this set of waves? And what a lot of people did was they took their frequency from part D and multiplied it by their amplitude. That is not the equation for speed. Speed equals wavelength times frequency. That's what that lambda means. You need to know what the lambda is. Don't just say, oh, I got a number here, I got a number there, I must need to multiply them. No, you need to know what you're multiplying, which equation you're using. Let's move on to the longitudinal wave. I'm just going to walk you through this one. So again, a wavelength. So let's go through this. So a label, a compression, and a rarefaction. So a compression would be this, where it's compressed, it's smushed together, it's being pressed, if that helps you, compression. And then rarefaction would be up right here, rarefaction. This section here is really spread out. All right. Now, what I said earlier was this is a slinky. All of these up and downs, those are the whirls on a slinky, not waves. So there are, from the beginning of the compression here to the beginning of compression there, that is one wavelength. That is one wave. The beginning of this compression, the end of the rarefaction, the beginning of the next, that is two waves. There are approximately 2 waves here. So now I need to measure that. The length of one of those waves is from the beginning here to beginning here. And I would say that's about 8 centimeters. I think I put 8.1 on the key. I was pretty generous with that one though, because it's a little tougher to measure. If it took 5 seconds for this set of waves to pass, so this is the time. Now it's 2 waves per 0.5, sorry, I think I said the wrong number. That would equal 4 hertz. That's its frequency. So its speed, velocity equals wavelength times frequency. Velocity equals wavelength, 8.1 centimeters, times frequency, 4 hertz. And then I plug it in and I get 32.4 centimeters per second. That was a really tough one. We really struggled with that. I'm going to point one other issue out that we had. Number 13 asks, which of the colors has the highest frequency? Well, you needed to know as wavelength increased, or excuse me, as wavelength decreased, frequency increased. But gamma is not a color. Purple or violet, any of that was acceptable as the highest frequency, right? So that is, gamma is not a color. Last but not least, we're going to go through the last chunk is on inversely and directly proportional. I'm going to just give you some practice with that. I'm going to ask you to do that as practice, but you should know what those are. If you don't, I'll put a link to the video about proportional relationships in that workspace. But I'm not going to go through that again because we know you should know that by now. If you need additional help, I'm happy to help you. You need to complete this worksheet and bring it in to me. Please do it as fast as possible, especially if you're not currently on track in my class. Hope this was helpful. Have a great day.